we have the system of linear equations like this. The first equation, that is x plus y plus z is equal to 6. If the pivot element is 0, how can I do the row operations? It is highly difficult, not at all possible. So which is the alternative option I have? In this case of Gauss elimination, we will make these elements, that is the lower triangular matrix, as 0. Hello everyone, it is Dr. Ravikumar YB. Once again, you are going to learn about the solving system of linear equations by the method of Gauss elimination. The system of linear equations, algebraic equations, appears frequently in many of the engineering problems. You have come across many of the engineering problems wherein you will find the system of linear equations, that is the numerical techniques which deals with different partial differential equations, which represents the governing equations of physical phenomena in the form of a system of linear algebraic equations. All these are examples wherein you will find the requirement of this Gauss elimination method. Gauss elimination method. Then Gauss elimination technique, which is a well-known numerical method which is employed in many scientific problems. Let me consider one of the equations here. In this case, I have the value a11 here, x1 here. So let me take that x1 is an unknown. We have an unknown here, and aij. What is the meaning of aij? I may be 1, j may be 1 here. That is first row, first column. First row, second column. First row, last column. That is nth column. So we have the value nth unknown. We have C1, which can be represented in the form of an augmented matrix. If that is the case, let me have one more thing here. Second row, first column. Second row, second column. Second row, nth column. So we have the second value, that is C2, constant. Then we have nth row, similarly, first column, nth row, second column, so on up to nth row, nth column, we have nth unknown and nth constant, which shall be represented in the form of an augmented matrix. So, if that is the case, we can represent it in the form of A into X equal to C, which is where A is the aij, that is the coefficient, X is the unknown, and C is a constant. This is a coefficient. X is an unknown which needs to be determined, and C is a constant. So we have all these things here. So let me consider one of the example wherein you have the set of linear equation, system of linear equations. Let me call this as equation 1, equation 2 and equation 3. We have the system of linear equations like this. The first equation, that is x plus y plus z is equal to 6, which can be represented as in terms of their coefficients, that is 1, 1, 1, 6 is equal to 6. The second system of linear equations can be represented in terms of 2, 1, minus 1 equal to 1. The third system of linear equations can be represented in terms of minus 1, 2, 2 equal to 9. If I represent it in the form of a matrix, I'll get the matrix in this form, that is the augmented matrix, that is 1, 1, 1, 6. I'll call this as like this. 2, 1, minus 1, 1. Minus 1, 2, 2, 9. So we have this kind of matrix is called as augmented matrix. Augmented matrix. Now we have this augmented matrix, the very first equation, that is this. We have the element which is 1. This is called as the pivot element. Please note that it is a pivot element. This must always be a non-zero. If it is 0, we have to interchange the equations. That is to be remembered here. If that is the case, let me rewrite the same equation, that is 1, 1, 6 here. 1, 1, 1, 6. that is the augmented matrix, 2, 1, minus 1, 2, 1, minus 1, 1. We have this term. Next we have minus 1, 2, 2, 9. Minus 1, 2, 2, 9. If that is the case, let me do some row operations. This is called as row 1 R1. This is called as R2. This is called as R3. Similarly, we have C1, column 1, column 2, column 3, column 4. This is column 4. We have the fourth element. Now, in this case, this is considered as AI, that is A11, A12, A13. This is as A21, A22, A23. Then we have A31, A32, A33. So, we have the diagonal element which is equal to A11, which is A22. Then we have A33. These diagonal elements must be considered here, and all other elements which is there in this called as lower triangular matrix. The items or the elements which are there in the upper part are called as upper triangular matrix. This is called as lower triangular matrix. Now, in this case of Gauss elimination, we will make these elements, that is the lower triangular matrix, as 0 by doing the row operations or column operations. How we are going to do that? Let me consider the equation with certain row operations. If I do the row operations, that is the lower triangular matrix as 0, this turns out to be some non-zero value which is equal to this. This is substituted into this equation to get the value another term. That is, by substituting the value of z into the previous equation, I'll get the value of y. By substituting the value of y and z into the previous equation, I'll get the value of x. So that the values of x, y and z are determined. So this is called as a back substitution. This is called as forward elimination. And back substitution. So combination of this forward elimination and back substitution together solves Gauss elimination. Solves the Gauss elimination problem. Now we have the term, that is the first row is multiplied by minus 2. If I subtract multiplied by minus 2, what happens? I have the value 2 here. So if I multiply it by 2, I'll get 2, 2, 2, 12. So let me rewrite the same thing. Let me rewrite the same thing here. That is 2, 2, 2, 12. I have the second term, that is the row, 2, 1, minus 1, 1. 2, 1, minus 1, 1. Which is the third row I have here. Minus 1, 2, 2, 9. Minus 1, 2, 2, 9. Now I have these two terms as same. So I will subtract row 1 from row 2. If that is the case, what happens? 2 minus 2, that turns out to be the value which is equal to 0 here. That is R2 is equal to R2 minus R1. That leads to the value 0 here. 2 minus 1, that turns out to be the value R2 minus R1. That turns out to be the value which is equal to minus 1 here. If I do the R2 minus R1. If I do R1 minus R2, what happens? 2 minus 1, that turns out to be the value, positive value, which is 1. Then I have 2 minus of minus 1, that is 1. That turns out to be the value 3 here. 12 minus 1. What is the value of that? It is 11. We have this term here after the operation, this row operation. We have the rest of the elements as it is minus 1, 2, 2, 9 and 2, 2, 2. If I do that operation, what happens? Let me keep the values as it is, that is 1, 1, 1. What is the value of that original value? That is 6. If that is the case, I am just going to do the row operation implicitly, that is 2 into R1, that leads to 2, 2, 2, 6 turns out to be 12. So that is subtracted from this row 2. So as a result of that, I have got the value which is 0 in the second row first element. Now I want to make this as 0. How can I make this as 0? I have a non-zero item here. If I multiply row 2, row 3 by some value, what is that some value? 2. What happens? 2 into minus 1, that turns out to be the value minus 2. Then if I add first row with last row, what happens? This element becomes 0. If that is the case, let me do the operations. Now I have the value which is this. Let me rewrite the same thing. 1116. 1116. 01311. 01311. Minus 1229. Minus 1229. We have this form. Now if I subtract this row 2 from row 3 from row 1, or if I add this row 3 from row 1, what happens? This becomes 0. That is, this turns out to be R3 is equal to R1 plus R2. That turns out to be the value which is equal to R1 plus R2. What is R1 plus R2? 1 plus of minus 1. That turns out to be 1 minus 1, 0. So this becomes 0. That is 1 plus 2, that is this becomes 3, and this becomes 1 plus 2, that is 3. We have the value 6 plus 9, that is 15. We have the value like this. I'll keep the second row as it is, 0, 1, 3, 11. And I'll keep the first row as it is, that is 1, 1, 1, 6. We have the elements like this. Now I have converted the values into a zeroth value in the lower triangular matrix, which is the next objective. I want to convert this as 0 so that the entire lower triangular matrix becomes 0. How can I do that? If I multiply this term, that is, if I do the operations like this, if I multiply this row 2, that is R2 by 3, what happens? If I multiply the R3, 3 times R2, that turns out to be 3. So we have 0 into 3, that is 0. So let me consider this row. 0 into 3, that is 0. 1 into 3, that turns out to be the value 3. 3 into 3, that turns out to be the value 9. 11 into 3, that turns out to be the value 33. But let me keep the values as it is. That is 11, 3, 1. But what is the calculation I have got here? I have got 3, which is 3. 3 minus 3, that turns out to be the value 0. This becomes 0. So this also becomes 0 minus 0, that turns out to be 0. So we have 9, because I am multiplying this 3 by 3, second row. 3 into 3, that is 9. 9 minus 3 is 6. We have got 6. 11 into 3, that is 33. 33 minus 15, I have the value 18. I have got the value like this. Let me keep the first row as it is, 1, 1, 1, 6. I have got the lower triangular matrix as 0. If that is the case, what is this term indicates? 6z is equal to 18. Z is equal to 18 by 6, which is equal to 3. So we have the value, that is z is equal to 3 now. If I substitute the value of z into this equation, what happens? That is, I have 1, 3 as the value, y plus 3z is equal to 11. If that is the case, 3 into 3, 9. That is, y is equal to 11 minus 9. We will get the value y is equal to 2. Now I have got the value of y and z. If I substitute this value into this equation, x, y, z is equal to 6. X plus y plus z is equal to 6. What is the value of y we have obtained? 2 plus 3, which is equal to 6. That is x plus 2. That is, what is, if I bring these terms in towards this side, what happens? It becomes minus x equal to 6 minus 2 minus 3, which is equal to x equal to 1. This is the value we have obtained. So the unknowns are x equal to 1, y is equal to 2, z is equal to 3. So these are the values we have obtained by the method of Gauss elimination. The same thing you are going to observe in this case. That is, the value of z is equal to 3, y is equal to 2, x equal to 1. So similarly, we have an algorithm for this. That is, the algorithm for this is k is equal to 1 to n minus 1 steps. For j is equal to 1 to k plus 1 steps. For j is equal to k plus 1 to n. What does these two for loops indicates? What does this for loop indicates? Let me show you the execution of that. See here, when we transform this algorithm into the coding part, we are going to get some values, that is finding the unknowns by the method of Gauss elimination. So which can be implemented either in Python or in C or in C++ or in any of these languages. So if that is the case, let me consider this AB, that is the terms called this. This is an augmented matrix. Again, we have A11, A12, so on up to A1n. We have B1. This, since it is row 1, let me call this as row 1. Similarly, A21, A22, A2n, so on up to B2. Let me call this as R2. Similarly, AM1, AM2, so on AMN, BM. So let me call this as RMth row. We have the items like this, elements like this. So let me consider the form in upper triangular matrix. To an upper triangular matrix, this is the lower triangular form. This becomes an upper triangular matrix. By solving these terms, I am going to get the values of D1, D2, so on up to Dm. So let me consider one more example here. In this process, I have this equation. Let me call this as equation 1 and equation 2 and equation 3. In this case, if you observe that there is a zeroth value in the x term, that is 0. 0 into x. That means there is nothing. There is nothing here. If there is nothing, what happens? How can I write this? 0, 1, 1 equal to 2. 2, 3. 2, it is z. Please note that it is z. 0, 3 is equal to 5. Z, x, y, y, z is equal to 3. This is x. So we have 1, 1, 1 equal to 3. If you observe that there is a pivot element which is 0. If the pivot element is 0, how can I do the row operations? It is highly difficult, not at all possible. So which is the alternative option I have? I can interchange the elements between these two. If that is the case, this becomes 2, 0, 3, 5, the augmented matrix. I will bring this to here so that 0, 1, 1, 2. What is the remaining row? That is 1, 1, 1, 1, 1, 3. I have a augmented matrix like this. Now the pivot element is a non-zero value. That is, pivot is non-zero. So that the operations can be performed now. Either row operation or column operations can be done now. If that is the case, let me consider the row operation. This is row 1, this is row 2, this is row 3. We have these elements. This item is obviously 0 already. So let me concentrate on this item. If I multiply this row 3 by 2, it becomes 2. 2, 2, 6. Then I will subtract this from this. So what happens? This becomes 0. 2 minus 0, that becomes 2 here. Again, 2 minus 3, it becomes minus 1. So 6 minus 5, it becomes 1. So if that is the case, let me carry out the operations like this. In the next slide, I am going to show that how it is going to be done. It is the operation. Which is that operation? R3 is equal to 2 times R3. That is 2 times R3. That is 2, 2, 2, 6. You will get 2 times R3, which is to be subtracted from this. How we are going to do that? R3 minus R1. As a result of this operation, I am going to write this here. Let me write down that operation here. If that is the case, it becomes 2035, 2035. Then we have 0112. Let me keep as it is the second row, 0112. Then we have 2226. 2 minus 2, that becomes 0. This term becomes 0. This term becomes 2. 2 minus 0, that is 2. Obviously, that remains 2. I have the value which is equal to 2 here. Then I have the value which is equal to 2 here. 2 minus 3, it becomes minus 1. It is minus 1. 6 minus 5, it becomes 1. Let me keep it in the original form, that is this. It is in the original form. Now I have made these two items as 0, elements as 0. Now I want to do this as 0. How can I do that? By multiplying the row R2 by 2, that is 2 times R2, then subtract it from row 3. If I do that operation, what happens? That is R3 is equal to R2, 2 times R2 minus R3. If I do this operation, what happens? 2 into 0, that is 0, that remains as it is. 2 into 1, 2. 2 minus 2, that is 0. That turns out to be the value 0 here. This is, let me keep as it is 1 in the original form. I am using this 2 into 1, that is 2. 2 minus of minus 1, this becomes 3. I have the value here. Then I have 0 as it is here. Let me keep the term in the original form as it is here. I am using, this is an R3. So I am changing only the R3, not the R2, which is in the original form. Let it be in the original form. That is 2. We have 1 here. That is 3. It is 3, not 1. It is 3. So let me keep it in the form of this 3. Then, which is the other value? 2035. So we have obtained 3 here. That is 3z is equal to 3, which is equal to z is equal to 1. I have got the value of 1 for the variable unknown z. Next, I will substitute this into this. That is y plus z is equal to 2. Y is equal to, what is the value of z? Y is equal to minus 1 plus 2. That is, I shifted this z towards this, it becomes minus z. So it is minus 1 plus 2. 2 minus 1 is 1. That is, y is equal to 1. Next, let me substitute the x and y and z into this equation. That is, these two terms into this equation, so that 2x plus 0y plus 3z is equal to 5. What is the value of z here? 1. Y is what? 0. Y is what? 1. 1 into 0, that turns out to be 0. 0 plus 1 is equal to 5. That is 2x plus, that is 1 into 3. That is, it becomes 3. Now we have 2x plus 3 is equal to 5. Let me do the operations. 2x equal to 5 minus 3. That is x, 2x equal to 2, x equal to 1. So we have found the values of unknowns, that is x, y, z. X equal to 1, y is equal to 1, z is equal to 1. These are the unknowns of x, y and z. We have determined with the help of this row operations. As a result of this, you will find the values of that. That is 1, 1, 1. X, y, z. The values of that. This is a unique solution. So with this, I am going to conclude the session of Gauss elimination method. If you come across any questions or doubts with respect to the solving of linear equations by the method of Gauss elimination, kindly come back to me during the live sessions so that I can solve all of your doubts and questions in the live session. Thank you very much. Thank you one and all.